Okay, for this choice, it says, or for this example, it says, a test consists of 12 multiple choice questions with 5 choices for each question. Guessing on each and every one again. What's the probability of getting at most 2 correct? So I want to be able to make sure that I get 0, 1, 2 correct at the most. So I've got to figure out what it would be if I were to get 0 correct. What it would be if I got 1 correct. What would it be if I got 2 correct? And add all of those up and get 0.558345. In your calculator, it's a binomial CDF problem where you're trying to find 2 or less. And you set up with the number that you are picking from and the probability of getting each one, 0.2, because there's 5 choices for each question. And then you want to go from 0 to 2. And it should spit out the same amount of numbers, or the same amount. And if you look here, I've listed from 0 to 12. And so you're saying this probability of getting at the most 2 correct is going to be the bulk of where people are, because they're guessing for every single one of the questions. And getting any of the other ones correct are 0.441654, because it should total to 1. So let me scan down a little bit. Let's try another problem. Let's try doing 3 or more correct. In 3 or more, you can tell what the number ends up equaling. 3 or more, 0.441654. And if you were to do it in a calculator, you'd have to do binomial CDF, and it's the same thing, 12 numbers, 0.2 for a probability, but we want to go from 3 to 12 and include all of them. If it's less than 3, another problem, you want to make sure that you're not including 3 at all. Or I'm sorry, greater than 3, you're not including 3 at all. So we'd want 4 through 12. And if I look upward here, we do the same thing with 4 through 12. And it would be a 0.20. So about a 20% chance that you would be guessing 4 or more correctly. So it would be pretty much a miracle that would be happening. 20% is pretty low. And that's how you use your calculator to do those problems.